So for branch offsets, let's take a look at this by answering the question, which of these branches will jump forward 4 instructions? So to understand that, let's go through the differences in these. So the first question is this one here. So the answer here is can't tell because conditional branches depend on the values in the registers. And that's true, but if you look at these, all of these are comparing R1 to R1. So R1 always equals R1, so they're all going to branch because it's branch equal. So it's not this one here. Now let's take a look at the first two. These two here have a branch that's 4 times as big as these ones here. And the question there is the offset specified in bytes or instructions? Well, in this case, it's specified in instructions. So we specify how much to offset in instructions, and then remember it gets shifted over by 2 bits or multiplied by 4 before it gets added to the PC. So it's neither one of these two here because these are in bytes and we want to specify it in instructions. All right, now we've got these two left, and the question is it 4 or 3 if we want to jump forward 4 instructions. And remember, there's this part about PC plus 4 being added in there. Is PC plus 4 added in or not? If it is, then we want to move 3, and if it's not, 4. And the answer is it's always added in. So we need to account for it, which means that if we want to go 4 ahead, we always do PC plus 4. So this always adds on 1 more instruction. So we need to add on 3 more instructions if we want to go forwards 4 instructions. So this is the instruction that will move forwards 4 instructions on the branch. Now let's take a look at this calculation. So here's our calculation here. We've got our branch, and now we want to move ahead 3. So what happens? Well, here's our iFormat instruction. We're going to code branch not equal, the 2 registers we look at, and the constant 3. So here's the constant 3. Now, how is this constant used to calculate the new address? Well, we take the current PC, we add 4, we sign extend our 16-bit immediate, and we shift it over by 2, and that gives us the next PC. So let's take a look. Here's our current 32-bit PC. We're going to add in 4. That's the binary 4. We're going to take the immediate from here, and we're going to put it over into this part of the adder, and we've shifted it over by 2, and then we're going to sign extend it. Now this is a positive number, so sign extend is going to be 0. And then we're going to add this up. So what you see here is that we've taken the value 3 and we've multiplied it by 4 when we shifted it over. So this is now the value 12. So this is binary 8 plus binary 4, so that's 12. And we're going to add into it binary 4. So we're going ahead 4 plus 12, or 16 bytes, which is going to be ahead 4 instructions. Now, let's take a look at practicing the branch offset. So here's some code, and the code is going to increment I inside the loop until it reaches 10. First, go through and identify the destination for the jump here, and then fill in the constant that we need to jump to that point. All right, so this branch here needs to jump back up here to add I, and so jumping that far is going to be relative. We don't need the PC, but we need to go back -1, -2 instructions. So to go back -2 instructions, we have to remember we have the PC plus 4 in there. So -2 instructions, this is our byte offsets, that's -8 bytes. But remember, this is going to be in instructions. So we're going to put in -3 here. That's going to jump back 1, 2, 3 instructions, but we add on +4 to get the new value, so that's going to get us to the right location.